Okay, now we're going to try to begin our conversation about reliability of these estimates. And we're going to build this argument first very intuitively. So we're not going to be methodologically perfectly correct to start out with, but we're going to try to build a firm, intuitive understanding of what's going on. Once we feel like we have a bit of an intuitive foundation, then we will sort of convert the argument into a very technically correct, even cookbook-like method for testing these hypotheses. But my feeling in this class is that you should strive to really understand what's going on when we conduct one of these classical hypothesis tests, okay? So from the last module where we introduced the foundation of hypothesis testing, just to recall, we have an estimate, alpha 1 hat. We can talk about a whole distribution of these estimates because we're imagining a world in which we have the possibility of drawing an infinite number of samples from the same population, re-estimating the same model, and then gathering all of these alpha 1 hat values and putting them into a probability distribution. Okay? By virtue of our assumption that the epsilons are normal, it must be that the y's are normal, and therefore the alpha 1 hats are normal. Okay? Next, we introduced the idea of the hypothesis, and we said that our a priori belief is here when possible. Okay? We'll justify that later. And we call the first part of the hypothesis the null, the second the alternative. Okay? And then we argued that as evidence that we should reject the null in favor of the alternative. Okay? We will take a very large alpha 1 hat. That is to say, if we estimate our model and we get an alpha 1 hat value that's sufficiently large, quote unquote, then we will be led to reject the null hypothesis that the true alpha 1 is less than or equal to 0. So that's the setup, okay? Now, I want to stop for a moment and contemplate the ways in which we could be wrong in drawing our conclusions, okay? So you'll recall from your statistics class that we have both type 1 and type 2 errors, right? A type 1 error is when we reject HO, but HO was true. Okay? A type 2 error was when we fail to reject HO, but HO was false. Okay? HO is either true or false, right? We don't know, but we're going to use some evidence and we're going to make an inference about whether it's true or false. And in making that inference, okay, we could reject HO in favor of our pet theory, okay, but in fact, HO could be true, okay? So we could have a true alpha 1 that is in fact less than or equal to 0, but we concluded based on our evidence that alpha 1 was greater than 0. That would be a type 1 error. Type 2 error would be the opposite of that in some sense. That's when we would fail to reject HO. That is to say, we would claim that in fact alpha 1 was less than or equal to 0, when in fact our pet theory that alpha 1 greater than 0 was true. Okay? So rejecting HO when HO is true, type 1 error. Failing to reject HO when HO is false, type 2 error, right?